Systems of equations. Systems of equations contain more than one equation. A system solution must make all equations in the system true. And what that means in terms of a graph is the intersection of the lines when graphed. That would be the solution. So you can do it two ways. You either graph the system and try to find the intersection point, which works out great if it's on an exact ordered pair, exact number. But it doesn't work out so great unless you're using a calculator, if it's somewhere in the middle and you have to figure out what it is. But we're going to learn how to do it graphically and we're going to learn how to do it mathematically. This section looks at it graphically. So let's say I have this system, x plus 2y equals 18, and minus 5x plus 2y equals 6. I want to know, is 2, 8, the ordered pair 2, 8, a solution to the system? So in order for 2, 8 to be a solution, I have to substitute 2 for an x, 8 for a y in both equations, and they have to both be true. So 2 comma 8, x is a 2, y is a 8. Now I'm using the first equation here, x plus 2y equals 18, this one right here. So I put in a 2 for x, so there's my x, there's my 2, plus 2 times y is an 8. That's supposed to be 18, so 2 plus 16 equals 18. Yes, 18 does equal 18, so that works, but I have to check out both of them. They both have to be true, not just one. So the second equation is minus 5x plus 2y equals 6. So again, substituting a 2 for x and an 8 for y, 2, 8. Minus 5 times 2 plus 2 times 8 is supposed to be a 6. Minus 10 plus 16 is 6. Yeah, 6 does equal 6, so yes. Since the ordered pair made all equations true in the system, it is a solution. Let's try another one. This one is terms of variables f1 and f2. And the two equations are 2f1 plus 4f2 equals 200, or f2 equals 2f1. The ordered pairs are in the form of f1, f2, so it's 18 and 41. I want to know if this is a solution. So f1 is a 18, f2 is a 41. So when I put in the first equation, when I put an 18 in for f1 and a 41 in for f2, so 2 times 18 plus 4 times 41, that's supposed to equal 200, and yes, that does work out. 200 does equal 200. But when I put it in the second equation, f2 equals 2 times f1, 41, does that equal 2 times 18? No, that one doesn't work. So this is not a solution. It must work in both. Even though it worked in one, it didn't work in the other. So what does it mean graphically? Graphing to find a solution to a system. So here I have x minus 3y equals 6, 2x plus 3y equals 3. These are two other equations that I'm using, and I want to know graphically what is the solution. So first thing I'm going to do is put it in slope-intercept form so that I can graph. It's a lot easier graphing in slope-intercept form. Solve each equation for y. So let's look at the first one. X minus 3y equals 6. First I want to subtract x from both sides. So I get minus 3y equals minus x plus 6. Again, I put the minus x first. Now I'm going to divide everything by negative 3. So divide the y, the x, and the 6 all by negative 3. So I get y equals a positive 1/3 x, and this comes out to a minus 2. So my slope is a positive 1/3, which means I'm going to go up 1, right 3. And my y-intercept is negative 2, or 0 minus 2. So the first thing I'll do is plot the 0 minus 2. So 0 minus 2 is right here. And I'm going to go up 1, right 3. That's that. Up 1, right 3. That's that one. If I wanted to go the opposite direction, remember the slope for a positive slope can have two positives or two negatives. So I could do this as well. Down 1 and right 3. So let's see that one. So from here, I can go down 1, right 3. That puts me right there. And then I just connect the dots and make my line. So the black line is from this equation here. Now let's do the second equation, which is right there. So solve it for y first. So subtract 2x from both sides. And again, when I subtract this side, I want to put the x term first. So 3y equals minus 2x plus 3. Divide by 3. Gotta clear the y. So everything gets divided by 3. And then I end up with y equals minus 2/3 x plus 1. So the minus 2/3 x slope means the negative either goes with the 2 or the 3. So I put it with the 2. So I'm going to go down to right 3. Here's my y-intercept, 0, 1. So that's in red. So 0, 1 is right here. I'm going to go down 2 and right 3. That puts me right there. I can do it again. Down 2 and right 3. That puts me right there. So when I connect these dots on that, this right here is where they intersect. And luckily, it is easy to see what it is. Over 3, down 1. So the ordered pair is a 3, 1. If you wanted to verify it to make sure that it was true, it must work in both equations to verify it. So that's what I did over here. I took both of the equations, y equals 1/3 x minus 2, and I plugged in 3 minus 1, 3 for an x, minus 1 for a y. So minus 1 equals 1/3 times 3 minus 2. 1/3 times 3 is 3 over 1, so that's a 1. Does minus 1 equal 2 minus 2? 1 minus 1 equals minus 1, yes. Now I tried on this one here. Y equals minus 2/3 x plus 1. So minus 1 equals minus 2/3 times 3 plus 1. So minus 1 does equal minus 2 plus 1. So yes, it works. So that is the solution to the system.